After 14 years of development, the most expensive and often troubled next-generation aircraft carrier, USS Gerald R Ford, is finally ready for deployment. The aircraft carrier cost $13.3 billion in total and was approved by the US Navy in late 2021. Initially, the aircraft carrier was expected to be deployed in 2017. 8 years after the construction began in 2009, which is more than the usual aircraft carrier building time frame of 5 years. But the difficulties in the development process and a series of delays due to reliability problems with multiple new technologies caused a 5-year delay over the already longer than usual building time frame. Even in the face of a global pandemic, the team has kept a lightning pace. And we will continue to do so for our Navy and our nation until as Gerald R Ford completes her post-delivery obligations and is fully available and ready for tasking by the fleet, spokesman Rory O'Connor told News back in July 2020. He estimated that PDT and 2 would be completed in 10 months, followed by full ship shock trials in 2021. Gerald R Ford, the first of the Ford-class aircraft carriers, which will eventually replace existing Nimitz-class carriers, will integrate a whole lot of new technologies as the new generation of aircraft carriers. The aircraft carrier was designed with a novel dual-band radar system, new electromagnetically powered aircraft launch catapults, and weapons elevators, new aircraft arresting gear. The first ship in the class, as Gerald R Ford, was delivered to the US Navy in May 2017 and commissioned in July 2017. The aircraft carrier completed a multi-week final deployment composite training unit exercise for certification as a combat deployable warship in April 2023. The second carrier, USS John F. Kennedy, was christened and launched in December 2019. The vessel is scheduled for delivery to the Navy in July 2025, while further ships of the class Enterprise and Doris Miller are expected to be delivered in March 2028 and February 2032, respectively. With a displacement of approximately 100,000, the Gerald R Ford class is larger than its predecessor, the Nimitz class, but accommodates between 500 and 900 fewer crew members. The Ford-class ships will have 23 new or upgraded systems compared to the Nimitz-class carriers. The manpower reduction was a key performance parameter added to the original 4 outlined in 2000 in the operational requirements document for the CVN-21 program. It is estimated that the new carrier technologies will lead to a 30% reduction in maintenance requirements, and a further crew workload reduction will be achieved through higher levels of automation. Other main differences in operational performance compared with the Nimitz class are increased sortie rates at 160 sorties a day, a weight and stability allowance over the 50-year operational service life of the ship, and increased electrical power generation and distribution to sustain the ship's advanced technology system. Another key performance requirement is interoperability. Gerald R Ford class aircraft carrier hull since the 1960s. All US Navy aircraft carriers have been built at Northrop Grumman Newport News. News extended its design and shipbuilding facilities with a new heavy plate workshop and burners, a new 5,000 thick plate press, covered assembly facilities, and a new 1050 capacity crane. News is using a suite of computer-aided design tools for the CVN-21 program, including a CATIA software suite for simulation of the production processes and a K-virtual environment package. The hull design is similar to that of the current Nimitz-class carriers, and with the same number of decks, the island is smaller and moved further towards the aft of the ship. The island has a composite mast with planar array radars, a volume search radar operating at E-end, and a multifunction radar X-band. It carries the stern-facing joint precision approach and landing system, which is based on the local area differential GPS rather than radar. The aircraft carrier traditionally carries the flag officer and 70 staff of the carrier battle group. The flag bridge, which was previously accommodated in the carrier's island, was relocated to a lower deck to reduce the size of the island. The ship's internal configuration and flight deck designs have significantly changed. The lower decks incorporate a flexible, rapidly reconfigurable layout, enabling different layouts and installation of new equipment in command, planning, and administration areas. The requirement to build in a weight and stability allowance will accommodate the added weight of new systems that will be installed over the 50-year operational life of the ship. Removal of one aircraft elevator unit and reducing the number of hangar bays from 3 to 2 contributed to a weight reduction of the vessels. The Gerald R Ford class can be armed with the Raytheon evolved Sea Sparrow missile, which defends against high-speed, highly maneuverable anti-ship missiles. The close-in weapon system is the rolling airframe missile from Raytheon and Ramses. Gerald R Ford class aircraft carrier performance. The carrier can carry up to 90 aircraft, including the F-35 Joint Strike Fighter, FA-18F Super Hornet, Etude Advanced Hawkeye, EA-18 Growler, electronic attack aircraft, mid-6-tier S helicopters, as well as unmanned air and combat vehicles, to the requirement for a higher sortie rate at 160 sorties a day with surges to a maximum of 220 sorties a day in times of crisis and intense air warfare activity led to design changes in the flight deck. The flight deck has a relocated small island, while there are 3 rather than 4 deck edge elevators. Deck extensions also increase the aircraft parking areas. Aircraft service stations are located near the 18 refueling and rearming stops. General Atomics was awarded the contract to develop the EMELS electromagnetic aircraft launch system, which uses a linear electromagnetic accelerator motor. EMELS demonstrators were tested at the Naval Air Systems Command Lakehurst Test Center in New Jersey. The EMELS replaces the current C-13 steam catapults traditionally used in vessels to launch aircraft, expanding the aircraft launch envelope for future manned or unmanned aircraft. EMELS technology offers the potential benefit of finer aircraft acceleration control, which leads to lower stress levels in the aircraft and pilots, provides a slower launch speed for unmanned air vehicles, and allows a wider window of wind over deck speed required for the launch sequence. The contract for the development of an advanced turboelectric restore gear was awarded to General Atomics. The electromagnetic motor applies control to the synthetic Arrestore cable to reduce the maximum tensions in the cable and reduce the peak load on the Arrestore hook and the aircraft fuselage. General Atomics and the US Navy completed successful turboprop arrestments of C-2A Greyhound, a 2C Plus Hawkeye, and a 2 Advanced Hawkeye aircraft using the advanced arresting gear during performance testing in 2018. The IX system also completed the first exploratory barricade arrestment test with an E-2C Plus Hawkeye aircraft in March 2019. The Gerald R Ford class aircraft carrier completed its flight deck certification and carrier air traffic control center certification in March 2022. Aircraft weapon loading. The flow of weapons to the aircraft stops on the flight deck was upgraded to accommodate the higher sortie rates. The ship carries stores of missiles and cannon rounds for fighter aircraft, bombs and air-to-surface missiles for strike aircraft, and torpedoes and depth charges for anti-submarine warfare aircraft. Weapons elevators take the weapon systems from the magazines to the weapons handling and assembly areas on the 2-level deck, and express weapons elevators are installed between the handling and assembly areas and the flight deck. The 2 companies selected by Northrop Grumman to create designs for the advanced weapons elevator are the Federal Equipment Company and Oldenburg Lakeshore. Deployment of all up rounds that are larger rather than traditional weapons that need assembling will require double-height magazines and storerooms, and will also impact the demand for weapon assembly facilities. The US Navy outlined a requirement for a minimum increase of 150% in the power generation capacity for the CVN-21 carrier compared with the Nimitz class carriers. The increased power capacity is required for the 4 electromagnetic aircraft launchers and for future systems such as directed energy weapons that might be feasible during the carrier's 50-year lifespan. Sensors. In October 2008, Raytheon was contracted to supply a version of the dual-band radar developed for the Zumwalt-class destroyer for installation on the Gerald R Ford. Northrop Grumman developed an advanced nuclear propulsion system with 2 reactors, 4 shafts, and a zonal electrical power distribution system for the carriers. Fairbanks Morse received a contract to supply emergency diesel generator sets for CVN-80 and CVN-81 carriers in February 2019. So that was it for today. Make sure to like and subscribe so that you never miss another video.